After watching this video lecture, students will be able to balance chemical equations. So balancing reactions is really important. During chemical reactions, the atoms that you start with in the reactant's side are going to be torn apart and reorganized and reattached to form products. So matter is not being created or destroyed during a chemical reaction. Just all the matter, all those atoms are just being rearranged into new products. Okay, so the steps for balancing chemical equations is first of all to write an unbalanced equation. We know how to do this. We've learned from our last lecture. You use your nomenclature and formula writing skills to write your ionic and covalent compounds. The next step is to start the balancing in the equation by starting with the most complex substance and ending with the least complex. And so what I mean by the most complex is usually something that has multiple different types of atoms in the molecule, or maybe even just a large type of atom. Least complex is obviously something that's going to have less different types of atoms within the molecule. The third thing we're going to do during balancing is to simplify coefficients to the smallest whole number. Okay, so if we have multiples of 2 or multiples of 3 in front of all of the reactants and products, you're going to divide through to simplify that. And of course, we're going to check the number of atoms on both sides. You make sure you have the same number of one atom type on the product side as you do on the reactant side. And then the last thing is you want to check that again and you'll be done with your balancing. So let's go ahead and do some practice. Okay, so we're going to go ahead and practice. So the first thing we need to do here, we have our equation written out in word form. We're going to go ahead and write our unbalanced equation. So we take our vocabulary. So it says here aluminum. Okay, so we have aluminum, Al, and copper 2 chloride. So I know that's going to be CuCl2. React to form copper and aluminum chloride. Okay, so what we're going to do here, obviously, we've written our equation. The next thing we're going to do is we're going to balance the most complicated molecule, or starting with the molecule that's most complicated first. Okay, so I would consider the AlCl3 the most complicated. It has 2 different types of atoms, as well as the most atoms in any of the examples that are possible. So what we do here, we look at aluminum. Okay, so Al, I have 1 Al on this side of the arrow. I have 1 Al over there. So at this point, we're good to go. Now, chlorines. I have 3 chlorines here and 2 chlorines there. Okay, so what I need to do is I need to find some multiples. So I'm going to put a 2 in front of here. 2 times 3 is going to give me 6 chlorines on this side. If I change the 3 to 3 here in front of the CuCl2, that's going to give me 6 chlorines on that side. Okay, so now that I've changed the coefficient in front of AlCl3 to a 2, I need to go back and double check my aluminum. I now have 2 aluminums on this side, so I need to put a coefficient of 2 there. Okay, now I'm going to come over here, right, and if I look at the coefficient of 3 there, that means I have 3 Cus on the left-hand side of the arrow, so I'm going to end with balancing with 3 Cus on the right-hand side. Notice I started with the most complex and ended with the least complex. Okay, I then check my coefficients. Can I divide through and simplify? The answer is no. Okay, and then I, of course, double check my answer here. Okay, so I have 2 aluminums on this side, 2 aluminums on the right-hand side. Okay, 3 coppers on the left, 3 coppers on the right. Okay, 6 chlorines on the left, 6 chlorines on the right. So I have a balanced chemical equation. Okay, and if we go ahead and we start this example here, we got magnesium reacting with oxygen. Okay, so remember it's O2. Okay, to combine to form MgO. Okay, most complex molecule is going to be here. So Mg on the right, there's 1. On the left, there is 1 as well. Okay, MgO, there's only 1 oxygen over here, but there's 2 over here. I'm going to put a coefficient of 2 in front of that. Okay, so now that I've changed the coefficient in front of the MgO, I've changed the number of oxygens, but I've also changed the number of magnesium. So if I look at the left-hand side here, I only have 1 magnesium, so I'm going to put a 2 in front of there. Okay, I see if I can reduce down my coefficients. The answer to that is no. Okay, and then, of course, I double-check my quantities. So I have 2 Mgs, 2 Mgs, 2 oxygens, 2 oxygens. I have a balanced chemical equation. Let's go ahead and let's look at another setup here. Okay, so we have sodium sulfite. Okay, we have Na2SO3. reacting with phosphoric acid. Okay, so H3PO4 to form H2SO3 and Na3PO4. So now that we've written out our unbalanced equation, we're going to start with the most complicated molecule. Now, as you can see, there's lots of options here for what might be the most complicated molecule. So let's go ahead and approach this from, whatever selection I make. They're basically all equally complicated. I'm going to start with the Na3PO4. Okay, now something I want you guys to notice is that the polyatomic, the PO4 and the PO4 end up on both sides of the arrow. In those situations, guys, when a polyatomic ends up on both sides of the arrow, you don't need to break it down as it's phosphorus and oxygen or whatever else it's made of. You can just balance it as its whole species. Okay, so you'll see me do this here. I have Na3PO4. Okay, so I have 3 sodiums on the right-hand side. On the left-hand side, I have 2 sodiums. So I'm going to go ahead and I'm going to put a 2 in front of my Na3PO4 and a 3 in front of my Na2SO3 over here. Okay, so I've balanced my number of sodiums. Now I have 2 phosphates on the right-hand side. Okay, and I only have 1 here, so I'm going to put a 2 in front. Okay, so I have 2 phosphates on the right. Now I have 2 phosphates on the left. Okay, now what I've done here is I've left my H2SO3 to be balanced last. Okay, now I could use the hydrogens or the sulfites to help me balance this last one. But if we go ahead, I'm gonna go ahead and look at my sulfites. I have 3 of them over here. If I put a 3 in front of that, right, I have 3 sulfites and 6 hydrogens, okay, which will balance out. Okay, so now I'm going to check if I can reduce down my coefficients. The answer is no. Okay, so the next thing I check is is everything balanced? Okay, I have 6 sodiums, 3 sulfites, 3 sulfites. I have 6 hydrogens, 2 phosphates, 2 phosphates. So I have a balanced chemical equation, and I can use this for the future.